A lot of these questions I've already gone over before, so I'm going to go through this very, very quickly. Number 25, it's asking for the area of a sector. So we go to our formula sheet. We look for the formula for area of a sector. There it is right there. In order to use that formula, we have to have theta. It has to be in radians, and we have to have r. They gave us theta. It is in radians, and we have r. So we have 1/2 times 2 pi over 3 times 4.5 squared. And they wanted this to be rounded to 2 decimal places. So if I wanted to make my life easier, I could cancel off these 2, so that'd give me one less thing to put in the calculator. But it's not a big deal. So I end up putting in the calculator 4.5 squared times pi, all divided by 3. Or if you left the 2's in there, then you'd have to put the 2's in there too. So squared times pi divided by 3. And you end up getting 21.21, 2 decimal places. And this was given to us in centimeters. And so it's going to be centimeters squared since it's area. These next two are the same thing. It's area of a sector. So same formula is being used here. In number 47, the formula is not usable right now because theta is not in radians. So I have to change 30 degrees to radians. Good news. 30 degrees is right here on our formula sheet. So all we have to do is rewrite that as pi over 6. Then we can go ahead and substitute it into our formula. So we have pi over 6 times 20 squared. This time we're going to round to 4 decimal places. So we have pi times 20 squared. Whoops, shoot. Pi times 20 squared divided by 12. So there's what it looked like. Pi times 20 squared divided by 12. And we're going to 4 decimal places this time. And this was in centimeters, and we're still doing area, so it's centimeters squared. This one right here is already in radians, so it's just a matter of plugging it in. Put the pi over 1. Put the 0.7 over 1. The 0.7 has to be squared. So in the calculator, I'm going to do 0.7 squared times pi divided by 2. So I just did all that. And I got 0.7697, because again, 4 decimal places. We were in inches, so it's square inches. Then for 5.2, up here it's asking us to find the reference angle. Remember that a reference angle is an angle in quadrant 1. So the first thing we have to do is make this thing positive. And we make it positive by doing a coterminal angle. So we're going to add 2 pi, or a complete rotation, to it. So we're going to add 6 pi over 3, changing that to the same denominator. So we have negative 5 pi over 3. So we're still not a positive angle. So we're going to add another 2 pi. So negative 5 pi over 3 plus 6 pi over 3, which is pi over 3, which is in quadrant 1, which is your reference angle. Remember, you're not ever going to be asked to do this. Instead, this is how we're going to use this. This says evaluate using a reference angle. We don't really talk about it that way. The way that we do it is we just look at the angle, figure out your ordered pair. It's a pi over 4. So pi over 4 has this ordered pair, square root of 2 over 2, square root of 2 over 2. Then I have to figure out what quadrant I'm in so I can affix the appropriate plus or minus signs based on the quadrant. 11 pi over 4, let's see. 11 pi over 4. All the way around would be 8 pi over 4, because that's equal to 2 pi. And then 9 pi over 4, 10 pi over 4, 11 pi over 4. So I'm right here in quadrant 2, which means my x value is negative and my y value is positive. So now that I have the ordered pair, now I go back and look at the trig function I have, which is cotangent. The formula for cotangent is the x value divided by the y value. So when I take something and divide it by itself, that's pretty easy. When one is positive and one is negative, it ends up being -1. 300 degrees. Again, I don't have these memorized according to degrees. So the first thing is I would never give you these in terms of degrees. These would always be given to you in terms of radians. So changing this to radians would be 5 pi over 3. Yep. And 240 is 120, which is 2 pi over 3, 4 pi over 3, I believe. Yep, 4 pi over 3. Okay, and then we do this the exact same way. So we go to pi over 3 and look at what our ordered pair is there, 1/2 square root of 3 over 2. Then we have to affix the appropriate plus and minuses depending on what quadrant 5 pi over 3 is in. 5 pi over 3 is right here in quadrant 4, so the x value is positive, the y value is negative. Whoops, negative, silly. Secant tells us to take 1 over the x value or to flip the x value. So you end up with 2. Here, 4 pi over 3, same ordered pair, but we're in a different quadrant now. 4 pi over 3 is right here in quadrant 3, so these are both negative. And then I have to take the cotangent, which is x divided by y. So x is -1/2 divided by negative square root of 3 over 2. So a negative divided by a negative is going to be a positive. The first fraction stays the same. I flip the second fraction. We have 1 over the square root of 3, and when I rationalize that, I get square root of 3 over 3. And then the last thing here, they wanted you to use a calculator to evaluate these. So first of all, since both of my angles are in radians, I make sure my calculator is in radians. There's no button for cotangent, so instead I'm going to do 1 over the tangent of 4 pi over 7. Same thing for cosecant. There's not a button for that, so I do 1 over the sine of pi over 4. So first, this one I'm going to do 1 divided by tangent, and then 4 pi divided by 7, and then enter. And I get -0.228, and I did not look at how far I have to round that to. So we'll just leave it like that. And then for this one, we're going to do 1 over the sine of pi over 4. So 1 divided by the sine of pi divided by 4. And then hit enter. We get 1.414.